Track 18.
Do you want to make a start on our Natural Earth project? I think our idea of a lightning safety presentation is great, don't you, Rachel?
Yes, I think it'll be really good. I have a few ideas already.
Oh, great! Me too. I think we should divide it into 2 parts. What to do if you're inside when lightning strikes and what to do if you're outside. What do you think?
That's good, but we need more. Something about planning for this kind of event, and also what to do if someone gets hit by lightning.
Oh, I can't believe I forgot that. Of course. Well, what should we talk about in the first part?
I think we should say it's important to be aware. Lightning is always before rain, so don't wait until it rains. As soon as you hear thunder or lightning, you should get inside.
OK, yes. And then if you're indoors, you should avoid water, stay away from doors and windows, and don't use the telephone.
Or any electrical equipment. In fact, if you can, switch it off first. And you should wait half an hour after the last clap of thunder before going back outside.
And if you're outside when it storms, you also need to avoid water. Try and get inside as soon as possible. There are certain things you should avoid. Open spaces, anything large and made of metal. And of course, the obvious one, trees.
But we should mention that if lightning strikes very near you, you need to crouch down.
Oh, is that right? I thought you had to stand still.
No, that's actually wrong. You're supposed to crouch down.
And put your hands over your ears. The noise can damage your hearing if you don't. OK, I think we've got quite a lot here. Only the last part to go. Now, what to do if someone gets hit?
I think we should say that it's very rare for someone to get hit by lightning. Our talk sounds as if there's danger all around. We should try and make it sound a bit more reassuring.
Yes, you're right. We'll say it doesn't happen often. It's just better to be safe than sorry. But what should we say about getting hit by lightning?
Well, I think we should say it's safe to touch people who've been hit by lightning. They don't have any electrical charge. If there's a first aider around, then they should help them. Otherwise, it's just best to call for an ambulance. And we should remind our audience that 80% of lightning victims don't get fatally injured. That should calm everyone's nerves.
Track 8. Track 9. IELTS practice task. You will hear part of a talk about a ship called the Yavari. Look at the task, then listen and answer questions 1 to 7.
Good evening. Tonight I'm going to tell you an amazing story about a remarkable ship called the Yavari. If you go to Lake Titicaca in Peru, which lies at 3,800 meters above sea level in the Andes Mountains, you can see the Yavari in Puno Bay, near to the big hotel. The boat is open to visitors every day, and a guided tour is available. You can even stay overnight on the boat, floating on the world's highest navigable waterway. It's quite an experience. But the Yavari didn't begin its life in Peru. When the rotting remains of the ship were discovered in Puno in 1983, people believed that it had been built at Glasgow in Scotland in 1905. But this proved not to be the case. It's actually much older, and research has shown that it was constructed in the city of Birmingham, in England in 1862. The ship, which is made mostly of iron, was ordered by the Peruvian government and constructed according to what was known as the pin-built method. In other words, the ship was made in England, then taken to pieces and shipped to Peru in small sections, arriving at the port of Arica on the coast. From there, it continued its journey by train, around 55 kilometers across the Atacama Desert to the foothills of the Andes, at which point the ship, split into 2,766 separate sections, was carried on horseback up to Lake Titicaca, where it was reassembled. The journey from England taking a total of 6 years. As well as transporting people and essential supplies to communities around the lake, the Yavari spent most of its working life collecting raw materials, such as precious metals and wool from around the lake, and bringing them to a central collection point from where they could be transported down to the coast. Lake Titicaca is so high that no trees grow there, and wood is not readily available, and there are no coal reserves locally. Even so, the ship was originally driven by a steam engine and needed a source of fuel. Until 1914, when a diesel engine was fitted, llama droppings provided the answer, a total of 1,400 bags of the stuff being needed to fuel a trip all the way around the lake.
Track 9. Track 14.
Hurricanes have heavy rains and are therefore more likely to cause floods. Droughts occur when there is a lack of rainfall. Hurricanes and typhoons are both violent storms that develop over water. If the storm develops in the Atlantic or Caribbean, it is referred to as a hurricane. If it develops in the Pacific, it is known as a typhoon. The largest glaciers in the world are found in the polar ice caps of Antarctica and Greenland. Glaciers are also found in mountains. A current is a steady flowing movement of air or water.
Track 14. Track 15. 1. Sentence A.
In freezing temperatures, water turns into ice and expands.
Sentence B.
Metal, on the other hand, contracts when cold.
2. Sentence A.
It is highly likely that glaciers will continue to melt.
Sentence B.
It is unlikely that they will melt as quickly as some climate experts had predicted.
3. Sentence A. Previous predictions were based on inaccurate data. Sentence B. More accurate information is now available. 4. Sentence A.
Some climate scientists may have overestimated the rate of global warming.
Sentence B.
Others may have underestimated the impact of climate change.
Track 15.
Section 2. You will hear a man talking on the radio about a national arts centre. First, you have some time to look at questions 11 to 16. Now listen carefully and answer questions 11 to 16.
Hello, and welcome to Focus on the Arts. I'm your host, Dave Green, and this is your very own local radio programme. Every Friday evening, we put the spotlight on different arts and culture facilities and look at the shows and events that are on offer in the coming week. And today, the focus is on the National Arts Centre. Now, if you don't already know it yourself, I'm sure you've all heard of it. It's famous throughout the world as one of the major venues for classical music. But did you know that it's actually much more than just a place to hear concerts? The centre itself is a huge complex that caters for a great range of arts. Under a single roof it houses concert rooms, theatres, cinemas, art galleries and a wonderful public library, as well as service facilities including 3 restaurants and a bookshop. So, at any one time, the choice of entertainment there is simply enormous. So, how did they manage to build such a big arts complex right in the heart of the city? Well, the area was completely destroyed by bombs during the war in 1940. So the opportunity was taken to create a cultural centre that would be what they called the city's gift to the nation. Of course, it took a while for such a big project to get started, but it was planned in the 60s, built in the 70s, and eventually opened to the public in 1983. Ever since then, it has proved to be a great success. It's not privately owned, like many arts centres, but is still in public hands. It's run by the City Council. Both our National Symphony Orchestra and National Theatre Company were involved in the planning of the project, and they're now based there, giving regular performances every week. And as the centre is open 363 days of the year, there are plenty of performances to choose from.
Before you hear the rest of the broadcast, you have some time to look at questions 17 to 20. Section Section 4. You will hear part of a lecture about an experimental design for a house. First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Good morning. In the last few lectures, I've been talking about the history of domestic building construction. But today, I want to begin looking at some contemporary experimental designs for housing. So, I'm going to start with a house which is constructed more or less under the ground. And one of the interesting things about this project is that the owners, both professionals but not architects, wanted to be closely involved, so they decided to manage the project themselves. Their chief aim was to create somewhere that was as environmentally friendly as possible. But at the same time, they wanted to live somewhere peaceful. They'd both grown up in a rural area and disliked urban life. So the first thing they did was to look for a site, and they found a disused stone quarry in a beautiful area. The price was relatively low, and they liked the idea of recycling the land, as it were. As it was, the quarry was an ugly blot on the landscape, and it wasn't productive any longer either. They consulted various architects and looked at a number of designs before finally deciding on one. As I've said, it was a design for a sort of underground house, and it was built into the earth itself, with 2 stories. The north, east, and west sides were set in the earth, and only the sloping south-facing side was exposed to the light. That was made of a double layer of very strong glass. There were also photovoltaic tiles fixed to the top and bottom of this sloping wall. These are tiles that are designed to store energy from the sun, and the walls had a layer of foam around them too to increase the insulation. Now, what is of interest to us about this project is the features which make the building energy efficient. Sunlight floods in through the glass wall, and to maximize it, there are lots of mirrors and windows inside the house. That helps to spread the light around. So that's the first thing. Light is utilized as fully as possible. In addition, the special tiles on the outside convert energy from the sun and generate some of the house's electricity. In fact, and it is possible that in future the house may even generate an electricity surplus, and that the owners will be able to sell some to the national grid. As well as that, wherever possible, recycled materials have been used. For example, the floors are made of reclaimed wood, and the owners haven't bought a single item of new furniture. They just kept what they already had. And then there's the system for dealing with the waste produced in the house. This is dealt with organically. It's purified by being filtered through reed beds which have been planted for that purpose in the garden. So the occupants of the house won't pollute the land or use any damaging chemicals. It's true that the actual construction of the house was harmful to the environment, mainly because they had to use massive amounts of concrete, one of the biggest sources of carbon dioxide in manufacturing. And, as you know, this is very damaging to the environment. In total, the house construction has released 70 tons of carbon dioxide into the air. Now that's a frightening thought. However, once the initial debt has been cleared, and it's been calculated that this will only take 15 years, this underground house won't cost anything, environmentally I mean, because unlike ordinary houses, it is run in a way that is completely environmentally friendly. So, eco-housing like this is likely to become much more.
That is the end of section 4. You now have half a minute to check your answers. Section 4.
Track 16.
In today's talk, I'm going to give you an overview of the most recent thinking on climate change. Recently, the IGPCC, the Intergovernmental Panel on Climate Change, has conducted a major review of the evidence for climate change. In its conclusions, it states that the evidence for global warming continues to be overwhelming. However, according to the panel, some of the risk factors identified in earlier reports have been overstated, whereas other impacts of global warming may have been understated. In this talk, I'm going to outline some of the overstated risk factors and explain the current position on each. I'll then mention briefly some of the aspects of global warming that are now considered to be a more serious problem than previously thought. One of the most significant revisions in the new report concerns estimates of rising sea levels. Previous studies had predicted that sea levels would rise by more than 2 meters. The latest evidence suggests that sea levels are likely to rise by no more than 1 meter. This is good news for many coastal areas, as flood defences currently in place are much more likely to cope with a rise of 1 meter. A rise of 2 meters would have required major investment in flood defences. The reason climate scientists have come up with such different predictions of sea level rises has to do with our understanding of what is happening to the major glaciers and ice sheets around the world. Some appear to be contracting faster than predicted, and others appear to be expanding. In 2007, for example, the IGPCC predicted that the Arctic would be ice-free in summer by 2080. The latest predictions bring this date forward by 20 years to 2060. In the Antarctic, on the other hand, the ice sheet appears to be expanding as seawater freezes over. This variability in ice sheet activity accounts for the differences in our predictions of rising sea levels. Another significant revision of our understanding of climate change concerns the Gulf Stream. As many of you probably know, the Gulf Stream is a current of warm seawater that travels from the tropics northeastwards across the Atlantic. It is responsible for keeping temperatures in Europe and North America 5 to 10 degrees warmer than they would be otherwise. An earlier study concluded that the flow rate of the Gulf Stream had decreased by 30% since the 1950s. It warned that the Northern Hemisphere could be heading for another ice age. In other words, a period of prolonged cold. However, a more recent study has indicated that currents of warm water have actually accelerated in the last 20 years. Climate scientists now believe that these differences are due to natural variability, and that the Gulf Stream is unlikely to disappear. This is good news for those who live in Europe and North America. I'd like to move on now and mention some of the consequences of global warming and some of the risk factors which may have been underestimated by previous studies. As far as consequences go, there is new evidence that tropical forests are more susceptible to drought than previously thought, and that the severity of severe weather events, such as hurricanes and typhoons, may have been underestimated in the past. This is particularly bad news for those who live in southern regions. More worrying, there is stronger evidence that thawing permafrost in northern regions is producing very high emissions of methane gas. As I explained in an earlier lecture, methane is a much more potent greenhouse gas than carbon dioxide. This thawing ground has the potential to significantly exacerbate climate change. I therefore have to conclude this talk by saying that, in spite of the good news on rising sea levels, global warming continues to be a serious cause for concern. To ignore it would be most irresponsible.